Hello, everyone. Welcome back to another episode of Space to Alive. We're back again after a short break with the Space Roundup with experts and astronomers Nick Howes and Terry Moseley. How are you guys doing tonight?
Very well.
Pretty good, pretty good. It's nice to see some sun at last after our little
Indeed.
summer holiday.
It is, and we have another great episode for everyone tuning in tonight, whether you're watching us on catch up or tuning in live. I hope you have a great show. I'll hand over to our experts. Have a great show.
Cheers,
Thanks.
Oh, it's been a long summer, hasn't it, Terry?
A nice one. Better weather here, maybe, than you had.
Oh yeah, you've had all the good weather. We've literally just for anyone who's not in the UK, we've had one of the wettest summers on record, which means astronomy's taken a bit of a backseat. Although lots of activity in the spaceflight sector, which is what we're going to start with. Virgin Galactic. So we covered this in our last show before we took our summer break. Virgin Galactic and Blue Origin, obviously in a kind of head-to-head billionaires battle as to who was going to be the first into space, in inverted commas, and there's all sorts of debate still raging about that one as to whether or not Virgin even made it into space, because the internationally recognised Kármán line is 100 kilometres and they didn't get there. Although the USAF classification, and if you want to go with the X-15 pilots, then they technically did get into space, but that's by the by. So Virgin Galactic have been decades now working towards this, obviously with Scale Composites working on Spaceship One, initially winning the fantastic Ansari X Prize, being the first crew to actually get into space where they did cross the Kármán line. So again, it kind of makes a bit of a mockery of the whole we're going into space when they're not, because their first flight did, and now all the subsequent flights, they just don't seem to have enough power to do it. Which brings us neatly on to the issue that's come about from this. So anyone who watched the rather abysmal stream, and it's got to be said it wasn't very good. I mean, the two streams that came out from Blue Origin with Wally Funk on board as well, that was really actually quite well done. But the thing with Blue Origin, it's a completely autonomous flight, whereas Virgin Galactic, of all of the three space companies, commercial space companies that are really vying for this commercial space business, Virgin Galactic are the only ones to do a crewed flight, as it were. So they actually have pilots on board who are piloting the craft, as it were. Now, the thing with that is, against an autonomous vehicle, obviously, there's a lot more skill required, and Virgin Galactic in the past have already had issues. I've forgotten how many years ago it was, but Mike Aylesbury sadly died when the feathering system on their spacecraft, when they were doing some of the test flights, failed at extremely high altitude, and that was a really sad loss, and that set Virgin back quite a number of years. It seems like Richard Branson's gung-ho approach to everything was gung-ho again. The fact that Branson was on board this, so you've got this multi-billionaire on board, this 18-year-old kid, some of his team on board as well, and it seems like as they were dropped from their kind of ascent aircraft at 50,000 feet, and we're powering up to space, as it were, for this kind of quick suborbital flick around, as it were, this shuttlecock type flick around, something went wrong. So a red warning light appeared, and red warning light should basically mean that the mission should be aborted. Now, the two crew on board, these are very experienced pilots. You've got Doug Mackay, who's a Scottish from Great Britain, pilot with years and years of experience. Mike Masucci as well, extremely qualified astronaut pilot. They took a call, now whether or not that was due to Branson being on board, to carry on and press through. And what happened was, basically, there's a kind of flight path which is filed with the Federal Air FAA, the Aviation Authority in the United States. And if you deviate from that, they will come and slap you on the wrist. And this is exactly what happened. So they had this flight cone warning, which basically meant that they were going in too shallow and there was going to be an issue with the descent. And they literally left their area of designated airspace that they declared they would be flying in for about 1.5 minutes. It was 1 minute 42 seconds for the entire duration of the flight, which in itself wasn't a particularly long flight. And yet, lo and behold, the FAA have come and slapped them on the wrist over this. Now, the implications of this could be quite dramatic. I mean, Virgin is saying that it was due to high wind speeds, it wasn't a major issue, etc. But the FAA can be extremely pedantic and very touchy when it comes to if you get things wrong. I mean, there's investigations currently ongoing as well, which we'll talk about a bit later with SpaceX, with environmental concerns with their launch site. And obviously, this has huge ramifications for what's being planned for UK launch as well, because UK launch, some of the bases up in Scotland, etc., have gone through inordinate hoops to get their range safety organised. Now, range safety, if you're launching from the likes of Vandenberg, these guys have been doing it for decades. If you're launching from the Cape, again, the reason why the Cape was selected was range trajectory. You're basically over the Atlantic. You're not crossing land. You're not really going to be hitting much. If you're going straight up in a vertical launch rocket, you're going to be reasonably safe. Same with the shuttle, but it was all extremely well planned. I mean, we're talking thousands of pages of documentation for contingency plans, where they'd land if something went wrong, what would happen if there was a catastrophic failure of the spacecraft, etc., which obviously happened with Challenger. And bits of that were raining down all over potentially fishing areas. So this, as I said, has got huge ramifications for the entire space sector. That if this gung-ho approach is the norm, people are going to die. At some point, people are going to die, and then we could be seeing a situation, much as we sadly saw with Columbia and Challenger, where you've got years of no more flights. You've got years of everyone being shut down and locked down. Now, this could have enormous ramifications for the future of commercial spaceflight. I don't know what you think, Terry, but to me, there's a lot going on here that could have lots of knock-on effects. That was the way I kind of saw it.
Yeah, the interesting thing is that Virgin were keeping quiet about it. In fact, this only emerged very recently. I wonder if they were actually hoping to get away with it. Probably very foolish if they did. As I understand it, actually, there were two warning lights. There was an amber or yellow warning light on the way up, showing that they were not climbing steeply enough. And that might have been the start of the problem. In other words, they weren't heading up into the aerospace that they were expecting to. So they had to alter that. Then when they got up to near the Kármán line, not exactly over it, they were slightly out of position, basically. So then when they start to glide back, that's when they went outside their flight envelope. Now, they're saying, there's a risk of collision and so on, but I would imagine that no other aircraft were anywhere near that area. The thing about the Spaceship Two is that when it's coming back down, it's just gliding. It has no engine power, so it can alter its direction slightly, but it can't climb up or do anything like that. So it's a serious issue if they go outside their flight envelope. And they didn't say anything about it at the time. So it was a bit naughty of them, I think, just to pretend that everything went very well. And as you say, yes, if the FAA want to really crack down on this and say you play by the rules and no exceptions, then there could be knock-on effects for everybody else. Nobody else has actually broken those flight envelope rules yet, as far as I know.
They haven't, but you've got to remember a few months back when SpaceX were testing Starship, and we'll go on to that story a little bit later, they had an explosion mid-air in fog. Now, again, the issue with that is potentially catastrophic if you've got, small aircraft in the vicinity, if you've got drones, all sorts of, so many things that could potentially go wrong. And range safety, as I said, with the UK, the range trajectories that are being planned from some of the launches in Sutherland and Shetland, etc., are going directly over the Faroe Islands, going over Iceland, going over huge amounts of fishing, potential fishing vessels. Obviously, if anyone's watching that fantastic drama on BBC One at the moment, Visual, there's a lot of submarines in that area as well, and a lot of covert kind of shipping and submarine craft as well. And you really don't want to get things wrong. So, and Virgin are planning, they've got 600 people with tickets for these flights. They're planning to get them all up within the next few years. I mean, they've got to obviously get a return on their investment. So anything that sets them back by, as much as 6 months or a year, if there was a really catastrophic failure or something, as you said, Terry, if they were hiding something and then it came to light, and luckily they got away with it this time. Nothing really went wrong, but it's a glider, as you said. It's like the shuttle. Comes back in, it's got no power. It's basically just a very, very high velocity glider. If something were to go wrong and they didn't get away with it and people were to be injured, don't forget the people who've paid for these flights, these 600 people, they're not exactly low profile individuals. These are, some very famous movie stars, pop stars, etc., etc. So let's just hope that this is a very interesting lesson learned and that they move on and
Yeah, better to learn now before there are any casualties. Yeah.
Indeed. So, taking us on to our next story. This one I really, really like, and Terry's going to lead on this. I love this story.
Right. This is completely new to me, a new word in the astronomical vocabulary. I'm not even sure of the correct pronunciation. Hycian planets or Hycian planets. And that name comes from the fact that they have a combination of plenty of hydrogen in the atmosphere and they're ocean worlds. So HY for hydrogen and CAAN for ocean. Hycian or Hycian, I don't know. Anyway, they have discovered or identified basically a new class of planets, about 2.5 times the size of the Earth and up to 10 times Earth mass. So they're they're super Earths, but instead of other super Earths, which are mainly rocky, these ones have basically a lot of ocean. So they're somewhere in between, say, a mini Neptune, which is mainly gaseous, and a super Earth, which would be up to maybe 2.5 times the size of the Earth, but basically rocky. And while we always think of oxygen as being necessary for the sort of life that we know, if there's water there, then obviously there's oxygen there as well, because water is H2O. They certainly detected hydrogen, plenty of hydrogen in the atmosphere. A lot of these, they think, are in the Milky Way. They're not always the easiest to discover for various reasons, which we won't go into, but there are quite a few candidates already. And they think that while they might not be suitable for advanced communicating life, they could certainly be a host to what we call extremophile life, the sort of bacteria that live in very extreme conditions on Earth, either deep down in the rocks, in the frozen wastes of Antarctica, down in the deep sea, in the hot smokers, and the almost unbelievable chemical maelstrom that you get in places like Yellowstone National Park, highly acidic, highly alkali. Bacteria, apparently, and other very simple forms of life can exist in these extreme conditions. And that's what we call extremophiles. They love the extreme conditions. Now, you're not going to be able to communicate with any life that's here, because it's basically nothing more advanced than algae. But what we think that the James Webb Space Telescope can do is detect a biosignature. They can detect chemicals in the atmosphere of this telescope, the new James Webb Space Telescope, could detect the biosignatures of this sort of life if it is there in the atmosphere of these planets. What they call the holotype is K218b. In other words, that's sort of the prototype. It's 124 light years away. They know that the planet is in the habitable zone of its star. There's water vapor in the atmosphere, and it's basically a whole new option for detecting life elsewhere in the Milky Way. As I say, it's not going to be intelligent life unless our assumptions are totally wrong, but to detect the biological signature of any form of life would certainly be a major step forward. What do you think, Nick?
I think it'd be really interesting to kind of almost do an inverse look back in this context. You think about our own planet, 75-76% covered in ocean anyway. So if you were to put something the equivalent of the James Webb at a far enough distance away, and obviously that's beyond our current technological capability, but that'd be fantastic to then look back at the Earth and say, right, can we detect biosignatures on the Earth? And you look at not only the James Webb, but the Square Kilometre Array as well, which I worked on many years ago, and it's finally coming to fruition now. This gigantic radio telescope, if Starlink and everything else doesn't decimate the radio bands, it will again be able to do all sorts of interesting detections relating to these atmospheres, because the resolution on the Square Kilometre Array is going to exceed the Hubble by 50 times, and the James Webb obviously is going to vastly exceed the Hubble. So between the spectroscopic observations from the James Webb and the SKA, I think this would be really interesting. Again, though, at 124 light years. What I found really interesting is, are the planets completely covered in water, or is it a large percentage of water? If it's a large percentage of water, and these are in the Goldilocks zone, then these are prime candidates for potential life forms. As you said, could be anything. I mean, this planet could be 3 billion years behind us. It could be 2 billion years ahead of us. We really don't know, until we get more detailed observations on it in terms of, estimating its planetary formation cycle and where it is, etc. I'd love to see something done that would do this look back. If you took a telescope out to the likes of where New Horizons is right now, and look back and said, right, even at that distance, which is only a few light hours, tens of light hours where Voyager is, you're at 17 light hours. If you could make a detection on the Earth that confirmed that there was life on this planet from those kind of distances as your kind of baseline, it's kind of your test article, as it were. If you can prove it that way, I think it'd be fantastic. That's what I would love to see on this. Again, though, 124 light years, unless Matthew McConaughey and Anne Hathaway suddenly pop out of Interstellar, we're not going to be going there. There's no black holes near Saturn, unfortunately, so we're not going to be doing that.
That's not the closest one, by the way, but as I say, it's what they call the holotype. Typical example. There are others that are a lot closer to their stars and maybe tidally locked. So very, very hot on one side and very cold on the other. Possibility of life in the intermediate zone. Or if there's a lot of water, then that water will transmit the heat very effectively from the hot side to what would normally be the cooler side. So there's all sorts of options. But yeah, I'm sure they could do that simulation of the look back. But until you actually sort of do it in real life, it's not the same thing.
That's the thing, unless you've got something that is cyclical, especially you look at the seasonal nature and the axial tilt of the Earth and the way that our seasons form and the way that things grow and disappear, as it were. Our Arctic and Antarctic ice sheets are currently rapidly diminishing due to climate change, and obviously we've got all the outgassing of methane from the Siberian tundra. There's lots of things like that. If you could get, it's like looking at Mars. At the moment, we still don't know where the methane's coming from on Mars.
Mm-hmm.
So. Yeah, and if we can't do that at only a few tens of millions of miles, it's going to be really interesting to categorically prove it, because that's the thing. If the James Webb team come out and say it's like the Venus phosphine on Venus a few months ago, when everyone got really excited, or a few people got really excited, and it's like, I'm not sure about this. You're always going to get objections until literally an alien comes and knocks on your front door and says, "Hi, I'm here." So it'd be wonderful to see. I'd love to see it happen. I think aiming for Proxima Centauri is more realistic, because they've obviously demonstrated now that their exoplanet's orbiting the nearest star to us, and I think that would be phenomenal just to get there and to see what was there. But anyway, it's a great story. Moving on, next up. So back to the naughty space billionaires. So Jeff Bezos, about a year ago at one of the international astronautical conferences, unveiled his vision for the Blue Origin lander for the Artemis missions. Basically, he was pitching Blue Origin and his own company and his own investment as well into the development of the first time we've been back to the moon since December 1972, since Gene Cernan and Jack Schmitt finally left the lunar surface in December of that year, nearly 50 years ago, which is quite terrifying in its own right. I loved the design of their lander. It looked practical. It looked viable. Bezos himself said he was going to inject loads and loads of cash into this. And then pandemic happened, and cutbacks happened, and the Senate happened, and the change in government happened. All sorts of things happened. And NASA's budget proposal, which was around about $3.5 billion for this lander concept. And don't forget, in the era of Apollo, between the Saturn V and all the various stages of that, these were all built by a range of different contractors. So you had like Northrop Grumman, you had Lockheed Martin, or Lockheed as it were, you had Boeing, you had a whole range of different companies working on various components of the Apollo missions. So the concept of having multiple organizations working on Artemis, even though Boeing are principally the prime contractor for the SLS, and we all know what's going wrong with that, and everything's delayed. And they're still having horrendous problems. And frankly, I wouldn't fly in anything Boeing were to fly at the moment anyway, because of their appalling safety record right now. And the fact that they, again, going back to what Terry was saying before, they were actually lying and covering up. And this is not a defamatory statement. This is what they were doing. This has been proven, that they were trying to hide issues with the 737 MAX, etc. Now the SLS is massively behind, massively over budget, etc., etc. But lots of different contractors are involved. So Jeff Bezos, as I said, he lauded this thing. It looked really good. Then along comes SpaceX with their giant rocket. Austin Powers, the movie Austin Powers, kind of springs to mind. If you've not seen it, watch it. You'll get the in joke there. It's a giant vertical rocket that's kind of silver, Starship concept. And essentially what they've said is they're going to build the lunar lander, and that's what's going to be landing on the surface of the moon. Now, I've got major doubts about that. Lunar regolith aside, and the lunar surface, and obviously SpaceX has still got some issues with Starship, as we'll be talking about in a little while. And this gigantic, really tall rocket, I mean, it's 165 feet high, and it's kind of full configuration Starship just on its own. So, you know, and a hatch at the top, it just doesn't make sense. Whereas the original LEM that was designed was it was archaic but beautiful. It was wonderful in its overall design concept, and did exactly what it was supposed to. Blue Origins looked like a kind of revamped version of that, bigger, obviously better, you know, vastly more computing power, etc., to assist with the landing. And they were going to be working alongside, you know, the MIT Instrument Lab, the JPL laboratories, who'd already done this for the Apollo landings. And then along comes SpaceX and steal everything and steal the thunder. So basically NASA, because of the budget cutbacks, couldn't down select more than one company. So they down selected SpaceX, because obviously they've got a lot of fingers and a lot of pies with SpaceX. SpaceX are obviously delivering their astronauts to the ISS. So there's got to be some, you know, some underhand dealings going on here to basically say, well, give us this contract or else, kind of thing. That's just my kind of thinking, but hey ho. So what happened is that SpaceX steamed in, they got the contract. Bezos wasn't happy about it. Now, Jeff Bezos is the richest man on the planet. And when NASA said, well, we can only afford $850 million for this, and which is a pittance, believe me, if you know, in terms of this kind of exploration work, it's a tiny amount. If Bezos says, right, well, if you're only going to give me $850 million, I'll fund the rest. He was literally prepared to put $2 billion of his own money into doing this, because the kudos and the kind of merit points, as it were, for saying that you have been part of the next step in some of the greatest developments in human history. I mean, the Apollo missions are still the greatest technical achievement in human history. Landing on the surface of the moon still to be beaten. Until we land on Mars, it won't be beaten in terms of a technical achievement from humankind. But he's not happy. So he's now suing NASA. And you think, well, after the billionaire kind of big boys spaceflight kind of duel, as it were, a few months ago, where you've got Richard Branson, and he's not exactly in most countries' best books. He tried to sue the National Health Service in the UK, which didn't enamor him to many people. Then he tried to get loads of money for furlough, even though he's a multi-billionaire, for his Virgin Atlantic operation. And Jeff Bezos, Amazon, most of us rely on Amazon one way or other for, if we're watching videos or get parcel deliveries. And I've got nothing against Bezos and Amazon per se, but he's not winning many friends by doing this, by suing NASA. It's not going down well. And, this bid from SpaceX, it's got federal backing. It's not like it's some underhand, just a couple of mates at NASA talking to Elon Musk and saying, yeah, you can have it. This has gone through federal approval. So it'll be interesting to see how this one pans out, but nobody's winning any friends. And if everybody's trying to push towards this bright future of commercial spaceflight and exploration, and this is what we want to see, I mean, Terry and myself in particular, definitely, we don't want to see a bunch of hippies going to Mars. We want to see exploration happening. And it'd be really interesting. I don't know what you think, Terry. I just think he's shot himself in the foot here a little bit.
Yeah, it's a bad case of sour grapes. I think the grounds in which he's suing is that they should have chosen two landers, so to have, a backup. And NASA said, yeah, well, suppose in an ideal world, that's fine, but we haven't got the money for it. And then, as you say, he offered to fund the rest of it himself. But I think the die had already been cast. The other interesting thing in it is, which sort of almost goes against this, is NASA are not terribly happy with Elon Musk at the moment, because he's spending far too much time and money on the Starship going for Mars, and he still hasn't delivered actually anybody into space on always mix up the name, but he hasn't delivered to NASA what he's supposed to do to get people up to the ISS. So I think they're a bit peeved that he's spending so much time and money and resources, and basically all his efforts are going into this beautiful, big, fantastic Starship, whereas he's actually contracted to deliver to NASA. But nevertheless, as you say, they chose him for the lander. So it's an interesting mixture of billionaire politics and coming up against NASA bureaucracy.
It is, and as I said, Elon Musk to some extent has got NASA over a barrel, because they need him. It's either that or pay the Russians at $75 million a pop to get an astronaut up on a Soyuz. And yes, the Soyuz is incredibly reliable, but the Russians are saying that the ISS is now literally falling apart, and they're pulling out of any kind of connection with the ISS over the coming years. China have obviously got their space station now being built, and ever growing, as it were, and at some stage in the future they're going to have even bigger space stations, no doubt. So NASA are in a kind of, they're in a very difficult position, I would say, right now, in that they've got massive budget overruns and delays with James Webb. They've got massive budget overruns and delays with the SLS. They don't have a proven technology yet, to get them back to the moon. They've got no alternative because of Boeing and the CST-100 and the issues that they've still got. I mean, that thing was supposed to go on its second test flight a month or so ago, and they had to pull it from the pad again because, again, there were issues with whatever on the spacecraft. And until they get that resolved, SpaceX is their only ticket. So Musk can literally say, well, you can't mess with me at the moment. Give me this, do this, do. Otherwise, they've got nobody on the ISS. They can't get cargo. They're reliant on the Dragon for doing the cargo. Obviously, they've got other JAXA and various others can deliver cargo. But in terms of human missions, it's either go with the Russians or go with SpaceX. So, rock in a hard place, I'd say. It'd be interesting to see how this pans out.
Yeah, it was the Crew Dragon was the name that just went out of my head there. So they want him really to concentrate on it. Of course, he can do both, but the NASA want him to concentrate on that and forget about Mars for a while.
Well, that's the thing. I mean, Crew Dragon, there's lots of commercial payloads being put on. I've got a friend who's got a set of patches that's gone up to the ISS on a Crew Dragon, and you can spend quite a small amount of money relative to what it used to be. It's in the tens to $20,000, as it were, to get a half decent sized payload on test on the ISS. So SpaceX have not only got them over a barrel, they've got them over a price barrel as well, because nobody else can deliver at the price. They've undercut everyone so enormously that it's, everybody's now scrabbling around thinking, how can we develop reusable rockets really quickly? How can we capture, Lockheed Martin are looking at capturing midair with some of the Scottish launches, if they even happen. It's a crazy time. It's moving really quickly, and I think there's going to be a lot of dead wood drifting away from this in the near future, and you'll be left with a few big players like we had probably in the governmental days of spaceflight, and these big players will be dominating most of the space market. You'll have the small launchers who'll launch the odd rocket here and there. Astra and Firefly, etc. They had some attempts again recently which failed, which is quite sad actually, because it'd be nice to see more and more players. You've got Peter Beck down in New Zealand who's doing a great job in terms of regular launches, but even he's had the odd mishap as well. So interesting times ahead, let's put it that way. Moving on to our next story, again another cracker.
This is another beauty of a story. A new record in the solar system, the fastest asteroid ever discovered, and the one that goes with its main distance closer to the sun. It rejoices in the name of 2021 PH7, which basically is the time and date of its discovery. Discovered on August the 13th, not by the sort of thing that you would expect. It was discovered by the Dark Energy Camera, which is actually basically designed to discover what dark energy is driving the universe's increasing expansion. It's on a 4-meter telescope down at Cerro Tololo Observatory in Chile, and it discovered a whole lot of things, but this was the unexpected, totally new a prize that they got. Basically, its orbital period is 113 days. Now that's a bit longer than Mercury, which is 88 days, but this thing has got a very elongated orbit, and that means it actually goes much closer to the sun than Mercury does. At its perihelion, it's only 12.4 million miles from the sun, so it gets practically red hot, maybe actually red hot, about 500 degrees. It is absolutely buzzing along when it's at its closest. It's traveling at 240,000 miles per hour when it's at perihelion, at its closest point to the sun. And a whole lot of interesting things about that. Because it is an elongated orbit and because it goes so close to the sun, it is very subject to a relativistic effect, which causes the perihelion, the closest point to the sun, to shift around in the orbit. Very interesting that actually the precession of the perihelion of Mercury was the very first thing that really demonstrated that Einstein's theory of relativity was correct, because Newtonian gravity couldn't explain that. So the whole lot of interesting things about this. It's not a big object, only about 1 kilometer in diameter, although if you get hit by something that size, you know all about it. It's the eccentricity of the orbit is 0.7, where 0 is basically a circle and 1 means that it's elongated to an ellipse, which stretches to infinity. So a very elongated orbit. It comes out just past the orbit of Venus at its furthest point from the sun. Reasonably high inclination of about 32 degrees to the main plane of the solar system. It's so unusual that they think actually it could possibly be the nucleus of an extinct comet, but at the moment, since it's not showing any cometary activity at all, it's classed as an asteroid. Now, it was only discovered, as I say, in August. It's now moving in its orbit in such a way that it's very, very difficult to observe because it's always close to the sun. So we'll not know a lot more about it until early in 2022 when the orbit shifts. But the most interesting thing about this is because the orbit is so unstable, they say it is possible that it collide with either Venus or Mercury or end up in the sun, or could possibly eventually be ejected from the solar system. It's classed as a near-Earth object because of its orbit, but it actually doesn't come particularly close to the Earth, not within about, I'd say, 20 million miles off the top of my head. But because the orbit is so unstable, partly because of the precession, it can come within about 1 million miles of Venus, and that's enough to perturb the orbit. The orbit is very unstable. Who knows what will happen in the future, but certainly in your lifetime and mine, it's not going to come anywhere close enough to the Earth to be dangerous, but it's just an absolutely weird, fascinating object. What do you think?
Well, it's amazing that out of, I think there's about 750,000 known and classified asteroids between, the asteroid belt and the Trojans, obviously near Jupiter, etc., etc. And there's only 20 of these known. It's a really, really rare type. It'd be great to get decent spectroscopic observations on it to, look at what type it is, if it's carbonaceous chondrite, much like the Winchcombe meteorite that struck the Earth, struck the UK not so long back. Finding out what its overall composition was. As you said, it gets extremely hot. I mean, I've heard 900 degrees.
I think that's Fahrenheit.
Yeah, closest approach, which is astonishing. It'd be fantastic to get more data on this, and who knows what else is out there. This is the thing. As you said, the Dark Energy Telescope wasn't really designed for this kind of work, and most telescopes, Earth-based observations, etc., and the space observatories like the Hubble, they don't point anywhere near the sun. So picking up stuff like this is really, really difficult, but really important, because as you said, some of the trajectories, the perturbations, as you said, it could come near to Mercury, it could come near to Venus. If you've got a perturbation at Venus and you've got certain trajectories, who knows what else could be thrown our way, but from a sunward direction, which would mean it'd be next to impossible pretty much to pick up until it may be too late. So, and 1 kilometer across, just to put that into context, meteor crater, the Barringer crater, it's misnamed as meteor crater, the Barringer crater, the massive one in Arizona, which is about 1 mile across and about 400 feet deep, that thing was 50 meters wide. So this thing's just so much bigger. If this was to hit, something 1 kilometer wide hit the Earth, it'd be devastating. It'd be absolutely devastating. So worth keeping an eye on. But loving meteorites. You can probably see the cabinets behind me. Loving meteorites as I do. This is a great one. It's one to keep an eye on. It'd be fantastic. Do you know what the magnitude was, Terry, in terms of
the discovery magnitude was about 19. The brightest that it can get is about 17, but that's when it's too close to sun to observe. The absolute magnitude, I made a note of it somewhere, is about 17 or 18. But basically, you're not going to see it in your average amateur telescope. A good imaging, CCD imaging telescope should get it. So there are amateurs who'll be able to pick this up, but you won't see it visually, I would say, in any telescope that an amateur has access to.
Yeah, 19 with a good sized backyard, like a 12-inch, Schmidt Cassegrain or a good sized Dobsonian that's got tracking on it, you'd definitely be able to pick that up. but again, be really risky because the proximity to the sun, you don't get it wrong.
It's obviously brightest when it's closer to the sun, but that's not what we want to see it.
No, that's the thing. In asteroids, if people don't know, typically the albedo, the reflectivity of most of the asteroids, you see these asteroid pictures and you think, oh, it's really, really bright. Well, they're not. They're actually about a quarter the albedo of coal. So if you had a lump of coal in a dark room, if you turned the lights off in a room and held up a lump of coal, you wouldn't be able to see it. And it goes to show you just how advanced the imaging capabilities are of most CCDs and telescopes these days. And this is why we've not really seen much out in the Oort cloud, as it were, which is still around the Earth, where they believe there could be trillions of comets, but we haven't seen any yet. In the Kuiper Belt, which is where New Horizons is, we've seen lots and lots of objects, but they're so dark. So again, seeing an asteroid, or potentially, as you said, it could be the inner core remnant of a comet. That'd be phenomenal if it was. That's a good one to spot. Anyway, on to our next story, because we're running. SpaceX. So we've talked about Virgin Galactic, we've talked about Blue Origin. We've got to kind of talk about SpaceX as well. They've now built the biggest rocket in the world. So since 1960 whatever, when the first Saturn V's were launched, the test of the Apollo 4 and Apollo 6 shaking itself to bits, etc. Apollo 7 was only a Saturn 1B, but essentially the Saturn V has been the largest rocket ever constructed by human beings at 383 feet tall. SpaceX have now beaten that. They've not launched it, but they have actually beaten it for a very short period of time. So they managed to stack put the kind of components together, the Starship, which is in itself is 165 feet tall, onto the Super Heavy, which is their booster system. This rocket, when it was put together for the brief period a few weeks ago, was about 400 feet high. So it beat the Saturn V. It was taller than the Saturn V. 29 Raptor engines. Now, if anyone remembers their history and remembers the Russian N1 rocket, so the Saturn V had the 5 F1 engines. Now, the F1 is still the most powerful liquid fueled rocket in the world in terms of engine capacity and thrust capability. It was generating 7.5 million pounds of thrust to lift a 7 million pound going in US units here rocket off the surface of the Earth. You're looking at something about the weight of a battleship off the surface of the Earth. The Saturn V was generating over the energy levels of the United Kingdom on launch. It was over 68 gigawatts of energy. The UK doesn't even use that when you're watching primetime television on Christmas Day. So for the first 1 minute 36 seconds of the Saturn V's launch, it was enormous. This thing is going to be bigger. And in terms of the acoustic energy being generated by this, if you're within a mile of this, you're dead. If you're within 3 miles of this, you're going to be shaken to pieces. 4 miles away was what the Saturn V typical launch distances were for people watching and observing it. SN20, I mean, their SNs, they're going up through the numbers. They've obviously now had a very successful test with Starship earlier this year, where they managed to take off and land vertically, 165-foot high rocket with only a few of these Raptor engines on board for gimbling and adjustment. It's one of those things where it is a love-hate relationship. We've said this many times with SpaceX. You've got to love their gumption and the fact that they've got the kind of turnaround mechanism and the recovery mechanism they've got planned for this. They're calling it the Mechzilla. So this is like a Godzilla scale kind of arm retraction system. So if you remember on the Saturn V, you had the launch tower, as it were, and then the tower arms would retract just before launch, and various bits would come away, the control umbilicals, etc., would come away, it would go on to internal power, and off it would go, and typically take anywhere between 5 to 10, sometimes a little bit longer seconds to clear the tower because it was so huge. With this thing, you've got these gigantic, they've not built them yet, so the loading was just on a standard crane, but they're planning these like huge capture arms. If that goes wrong, that's going to be spectacular. It's going to make, again, going back to the history, the N1 rocket, the Russian N1 was their equivalent to the Saturn V, and it used a very similar engine configuration, lots and lots of smaller engines kind of stacked together. They never managed to get the thing into orbit. It blew up on the pad. It blew up after takeoff. It caused the largest non-nuclear explosion in human history created by human beings. Killed tens of people on the pad in doing so. Because if you've got a rocket that's essentially the same height as the Saturn V, theirs was a little bit shorter, about 375 feet high, but just loaded up with fuel. It was basically a small hydrogen bomb. Yeah, it's going to be interesting, but again, my hat has to tip to Elon Musk, and really grates me to say this because of my hatred of Starlink and everything that's doing. But with this, it's just beautiful to see, and the design, etc. I mean, now they've got this kind of twin color design, it looks fantastic as well, and the lift capability of it is just extraordinary. I mean, this thing could literally lift a small ship into orbit. I don't know what you think, Terry, about when you saw it. It was impressive.
Yeah, I like the Maxilla idea, and actually it has a whole lot of benefits. It means he'll be able to do away with the landing legs on the first stage, because the thing will come down and be captured by this Godzilla mechanism. So that saves a bit of weight on launch. And as you know, every kilo that you save at launch saves you a whole lot of fuel and a whole lot of energy, and allows more weight for payload and so on. The other thing is that he says that if this works, the rocket will be ready to launch again in 2.5 hours. It will come back down basically onto its launch pad. You just fuel it up, press the button, and away it goes again. Now, as you say, this is only planned, but never doubt that Elon Musk, even though something sounds impossible or very unlikely, he can deliver. So as you say, when this thing goes up, you don't want to be close to it. It literally shake your insides to pieces, you know.
It's like go on, sorry.
Go ahead. No, go ahead.
The story about Walter Cronkite with the Saturn V launches, when he basically said, "I want to be closer," and they built him a little hut. With a great video on YouTube of literally Walter Cronkite saying, "The building's falling down around me." If you go too close. I mean, I know lots of friends who've seen Saturn V's launch in the past and have seen shuttles launch, and they'll say the rumble in your chest, even with a shuttle, which was a quarter of the size, pretty much, of a Saturn V, was absolutely, was groundbreaking, as it were, putting it mildly. So watching this take off. The interesting thing, though, again, going back to the FAA and their kind of restrictions, they've got some serious issues again with Musk and the environmental impact. So again, working with the UK Space Agency and a lot of the organisations in the UK who are aiming for UK launch have been, there's a lot of work been going into the environmental impact risk assessments, and a lot of work gone on up in Shetland, etc., by all the organisations involved. And it's a lot of work to do this. I mean, the NASA one is, again, hundreds of pages, because you've got to look at the risk to local wildlife, the risk to all sorts of different things. The FAA have got serious objections coming in now from people in the Boca Chica and the South Texas region as to what Musk is doing and the potential environmental impact of this. So there's a lot of, I don't know if it's people just anti-space in some respects, or they're just kind of concerned. And if it's just genuine concern, fair enough. If it's we don't need space because the Earth is flat kind of mindset, then that's fundamentally wrong. But again, he's got a bit of a fight on his hands. I wouldn't say he's going to lose. There's too much at stake here in terms of NASA and the future of commercial spaceflight, human spaceflight in particular, and Starship. If this configuration works, this will be going to the moon. This will be going to Mars. Within short periods of time, definitely, possibly even ahead of the SLS. Who knows? Musk, again, as Terry said, don't bet against him. Never, ever, ever bet against him, because you generally lose. He may have his flaws, he may have his issues, but you've got to admire him and his team, his vision, and the engineering prowess of the people who work for him. And if they're working 100-hour weeks, they're doing it for a reason. People I know worked on Apollo. They were working those kind of hours as well, because they knew they were making a huge difference to the future of humanity. So all power to him, I suppose.
Mm-hmm.
Anyway, brings us on to our last story, and then again another good one. Over to you, Terry.
Yep, we've talked about Mars already. This is actually happening. The Perseverance rover on Mars, Percy for short. If you've been following this at all, you'll be absolutely amazed at the helicopter flights and the aerial imaging, and even the close-ups of the rocks that the cameras are taking. Absolutely fascinating for Martian geologists. But one thing that they had failed to do on the first occasion was to drill and retain a sample of rock. I'll go on to a little bit more on that later. They have a drill which drilled into a rock about a month ago and attempted to extract a sample, but the rock that they chose was so soft and crumbly that it basically just turned to sand or grit, and they weren't able to extract the sample. So they moved on about half a mile, tried again with a different rock, a rock called Rochette. All this happening in Jezero Crater, which is an ancient lake and riverbed area, and they think a prime site for the possible detection of ancient Martian life, which is the main mission, if you like, of the Perseverance mission. So they chose another rock, and this time they were successful. They drilled in. It's only a small sample. It's just a bit thicker than a pencil, but they drilled into the rock. They extracted the sample, they filmed it, they made sure that it was indeed just exactly what they wanted, and it's now been stored in an airtight titanium sample tube. So what happens next? Well, not very much with that particular sample for quite a while, but the next, it's going to take a whole lot of other samples from different rocks. The next stage, which will happen in a couple of years, is that a joint NASA and ESA mission called the Mars Sample Return Mission will go out to Mars, and a very complicated series of maneuvers will actually retrieve these samples and bring them back to Earth. And no doubt we'll be talking more about that in the future. But basically, Perseverance is going to collect a whole lot of samples, bring them back to a single site. In the future, then, this Mars Sample Return Mission will go land there, and another rocket will collect those, take off, go back up and rendezvous with another spacecraft in orbit around Mars, and that will bring them back to Earth. They'll be hermetically sealed, and that'll be the first time that we have actually been able to take samples from another planet, chosen not just, say, Martian meteorites or something, which we know very little about in terms of their origin, but sampled directly from the surface of Mars, sealed hermetically, brought back, and be able to study it in the laboratory. This is only the first stage, but almost everything now that you're getting from Perseverance, the helicopter and the photographs on, totally amazing. And this is yet another significant milestone. So it'll be amazing to see how they continue and get other samples, and eventually they'll be bringing those back to Earth for study in the lab.
No, it's interesting. I've had, again, the company I work for, we've had a little bit of involvement in some of the discussions on this for the sample return, because there's some UK companies involved with the development of the lab. And obviously, back in the Apollo days, again, you had the lunar receiving lab, and everything, again, had to be quite well sealed. You know, you hear stories of Charlie Duke accidentally dumping a load of rocks onto his carpet in front of his kids after Apollo 16. But, I mean, most of the rocks that came back were sealed. Some of them have only recently been opened, and some of them are still sealed because they're waiting, obviously, for science to kind of catch up with the research that's now possible. And some of the research on the lunar rocks that's been done in the UK and various other sites around the world is amazing, looking at things like the moon's transit around our galaxy, which is anyone who knows our solar system kind of transits around the galaxy around every 250 million years. So every 250 million years you've got this cycle going around, and the moon's surface is a fantastic way to capture what it's passing through and what's happening. So there's all sorts of really interesting science there. Obviously we've got Martian meteorites. I've got a few in the cabinets behind me, but as Terry said, they're not pristine. These have come through Earth's atmosphere. They've undergone ablation in the Earth's atmosphere. They've hit the ground. Even if they've been picked up as quickly as possible and covered in fusion crust, they're still altered. They're still, they're structurally altered because they've been in deep space for however many tens, thousands, millions of years, and the transit time between being blasted off the surface of Mars by an impact from whatever, who knows what, and then transferred obviously into Earth. So this will be really interesting, and this multi-stage approach seems like a logical one, I must admit. Good luck to the European Space Agency, because in 50 years of trying between the European Space Agency and the Russian/Soviet Union, they've never successfully got anything onto the surface of Mars, apart from Beagle 2, which landed successfully but then didn't work, and the Mars 3 mission, which landed successfully, did work, but only worked for about 12 seconds and transmitted about 3 lines of data. So it's almost like the great galactic ghoul, as it's known, with Mars, does seem to swallow up a lot of things. The Americans have had a lot of success. Obviously, China, first go, Bosch, phenomenal to see that happen. And again, not only delivering, to the surface of Mars, but delivering a rover and a lander to the surface of Mars, and a very successful orbiter. So it proves it can be done. So all fingers crossed for the European Space Agency and NASA on that one. And then the sample return mission with these cores that are in these tubes. It'll be fantastic. My question is, going back to our previous story, if SpaceX get there first, all of this will be moot. because you'll have humans on the surface. And you've got two factors to consider there. One, you've got, as they said in the movie The Andromeda Strain, the dirtiest thing in the solar system, i.e. human beings, on the surface of a pristine 4.5 billion-year-old planet. And notwithstanding the fact that Schiaparelli and European Space Agency dumped a ton of hydrazine all over the surface of Mars and, planetary protection, everyone tries their best, but I'd say there's a few governmental organizations out there who haven't done their best over the years, the Russians in particular. So this contamination of the planet. But if you're going to put humans on the surface of Mars who aren't scientifically trained, who aren't real scientists, who are really aiming for biologically pristine suits, as it were, who knows? But if you can put scientists on the surface of Mars and you can put a laboratory on the surface of Mars, and don't forget with Beagles, they managed to get a spectroscope, a gas chromatograph, etc., down from the size of like a reasonably sized cupboard to a shoebox for the Beagle missions. It was incredible engineering feat. So I think if Musk or whoever manages to get to the surface of Mars, I mean, these sample return missions, we're not looking until probably 2030, 2031 before they're going to get back into Earth orbit, let alone start being analysed on the ground. At Musk's current rate, he could beat them. He could literally get to Mars before even a robotic sample return mission has gone back. So who knows? Let's see, but it is wonderful. It's fantastic, and I love, the Sky Crane. The fact that NASA have done it twice now. Stelzner and his team, and it's not just Adam Stelzner. There's a whole ton of people involved in that landing. Did a remarkable job getting something the size of a Mini Cooper onto the surface of Mars yet again. That's again doing great science. So all power to them. But let's just hope it all works.
If Bezos can bring back a few kilos of Mars rock and oxygen them off, he'll make even more money.
Well, this is the thing, Terry. As you know, the lunar samples are some of the most valuable. They're not commercially available. Nobody can buy them. It's a federal offence to own them unless it's attached to the artifact. So I have a tiny, tiny piece of Apollo 16 sample return, but it's still attached to the netting from the command module, or from it was the command module actually when they were doing the transfers, etc. So. It's really, really tiny. I mean, you need a good sized magnifying glass just to see it. But it's one of those things that, it's a federal offence to own them unless it's attached to an artifact. And there's loads of people who go all over the world trying to find the people who've stolen them. And yourself from Dunsink Observatory, the landfill in Dublin, which has got a $400,000 tiny fragment of the moon somewhere buried in it after the fire. It's really fascinating, but Mars sample. Don't forget with the Apollo missions, they brought back hundreds of kilograms, and these sample cores are just a few, like tens to hundreds of grams. So, if Musk can do it, all bets are off. He would make a lot of money. I mean, the meteorite community would go nuts for that. Anyone would owning a piece of.
I mean, he's not bound by NASA rules. He can sell them for whatever he wants to, whoever he wants.
Yeah. Various members of his team have approached me on many, because I collect Apollo memorabilia as well, and lots of his team have approached me in the past saying, "Oh, would you like to buy a piece of a Dragon did this, or a piece of a parachute?" I'm like, no, not really. But there's lots of people out there, so you could recoup an awful lot of money doing that. Anyway, our final catch up. What are we looking at for, Terry?
Yeah, it's actually a reasonably quiet time, but I have just lost my picture. Can you still hear me?
I can. Yeah. Still going.
Right. Okay. I've lost my picture, but never mind. One thing before we go on to what we can see at the moment, a very interesting thing with the Perseids, which we talked about before, which reached maximum in the middle of August. They were seen, reasonably well from the UK and Ireland, although there was mixed weather. But apparently there was a period of very enhanced activity where the hourly rate shot up to about double. But it was after the sunrise here in UK, Ireland, but it was seen in America. So even sort of a shower that we think is reasonably stable and so on, like the Perseids, can sometimes surprise. So hopefully we'll be able to see something like that. Some of the other meteor showers coming up, we'll talk about them later. But what we can see, the main things in the sky at the moment are particularly Jupiter and Saturn, which are just past opposition. Jupiter is by far the brightest object. in the sky as we see it from here. Venus is brighter, but it's very, very low down from our latitude. The Americans see it much better than we do because they're further south. It's barely visible low down in the twilight, and it is brighter. But the thing is that we can see easily Jupiter shining very, very brightly above the southern sky, round about local midnight, and Saturn over to the right of it, considerably fainter, partly because the rings are now, as we say, closing. The angle of the rings presented to the Earth is getting narrower, so they reflect less light. But if you have any sort of a telescope at all, or even good binoculars, have a look at Jupiter. You'll see the four main moons. If you look long enough, obviously they orbit around the planet. They're not always visible, but if you look for a couple of nights, you'll certainly see 3 or 4 of them, of the bright Galilean moons. And with a telescope, you can see them actually crossing in front of the planet, and the shadows crossing in front of the planet as well. But one of the most interesting things at this time of the year, you don't need a telescope at all to see, is how quickly the nights are shortening, because we're approaching the equinox, which will actually be on the night of our next webinar. If you think round about midsummer and midwinter, the days stay roughly the same length for about a week on either side of the solstice, either the summer solstice or the winter solstice, because the sun isn't moving very much further north or further south at those times. But as we approach the equinox at the moment, the sun is moving much further south every night, and that makes the days get noticeably short. I noticed when I'm out in the garden, I'm losing valuable gardening time every night at a considerable rate, and that is simply because with the angle of the ecliptic to the horizon, the sun is moving further south in the sky at its fastest rate round about now and up until basically into early October. So if you're not an outdoors type, maybe you don't notice it all that much, but if you're going out taking the dog for a walk in the evenings, you will notice just how quickly the nights are shortening. So that's it.
With Jupiter, I mean, I don't know if you saw it, Terry. Christopher Go, who is one of the most incredible planetary. I mean, there's Damien Peach, obviously in the UK, Chris Go, Paul Hees in Australia. There's some really renowned kind of amateur planetary observers. But Chris Go's video of that triple transit, where you've got not only details on the moons, and don't forget what we're talking about here. This is a backyard telescope imaging details on moons orbiting Jupiter. So we're looking at 500 million miles away, kind of for the first part, and then he's capturing not only these triple transits, but the shadows. I'm just watching a kind of cycling video of this on the Washington Post website. If you want to Google it, Christopher Go Jupiter images, it's absolutely stunning watching the rotation. And then obviously you've got the Juno spacecraft orbiting Jupiter at a very close distance at the moment, creating the most stunning visual images of the planet's surface, and obviously the moons as well. So Jupiter, if you've not seen it, if you get a chance, there's a big event happening in the West Country in October called the Dark Skies Festival. Please come along to that if you get a chance. If you're in the kind of Wiltshire area near Marlborough, there's going to be loads of telescopes set up there. I know Terry does phenomenal amounts of outreach over in Ireland with you and your kind of team of people, and the amount of work that you do in terms of encouraging people to do STEM, etc., and getting involved in astronomy. Jupiter and Saturn not so much as you say, because the rings are closing up, but Jupiter is one of those things that kids just go, wow, because you can see so much. It's like you look at the moon and you think that's amazing. You can see the craters and you can see things like Hadley Rill at certain times, and you can say, well, that's where the Apollo 15 landed, and this is where Apollo 11 landed, etc. But Jupiter, it's just so special, especially seeing those 4 little dots either side and saying, well, that's Gaia, that's Io, Ganymede, Callisto, Europa. That's got ice on it, that's got volcanoes on it, and it's amazing. And I'm just waiting now, looking at how the amateur images are getting better and better all the time. And a few years ago, Damien was almost in a league on his own. Now there's so many other people who have got the same kind of capability, the same kind of cameras, really good backyard telescopes, and they're knocking out phenomenal images, showing so much detail on the moons. I'm waiting for the first amateur image of a volcano exploding on Io. Somebody's going to do it. And I said this to Damien about 10 years ago. I said, what's the challenge left? And he said, I'm not sure. And I said, what, an Io volcanic eruption? And he said, don't know if that's even possible. I think it is. I think with a decent sized backyard telescope and the right filters, etc., and the right volcano at the right kind of point on the moon's surface, as it were, you'd get it. You get the flash. I think you get a flash or something. We'll see. It'd be wonderful to see that, because obviously going back to the Voyager days, that's how they first saw that Io was volcanic. Was just some young intern, as it were, looking at the images and saw something anomalous, thought it was another moon behind it. It wasn't. It was a volcanic plume. So who knows what we'll see. But it's interesting, and we're getting towards the darker nights now. We've got a bit of clear sky here in the UK. If you've got clear sky, please, if you've got kids, take them out, show them Saturn, show them Jupiter. Even with a modest telescope, it's amazing to see. And if you don't have access to a telescope, there's loads of robotic ones all over the world that you can dial into and get access. But seeing it with your own eyes is really something special.
Yeah. If you look at Europa, and if you have a better telescope and can see Enceladus, one of the fainter moons of Saturn, you're looking at two of the prime sites for the existence of life elsewhere in the solar system. Mars, Europa, and Enceladus are the prime candidates, possibly Titan, but it would be a different sort of life, because it's basically a methane type atmosphere. Yeah. But it's amazing to look with your binoculars and see that little point going around Jupiter and say there may possibly be some form of life on that.
Yeah, it really is. It really is. Anyway, so that's it for our show. Our first one back after the summer holidays. We'll be back in 2 weeks' time, and we'll be doing every 2 weeks now for however long. And hopefully now that lockdown and all this has ended, or pretty much, I know I'm going to be back at Harwell pretty soon to meet up with some friends there, see the guys at the space store. Terry, get yourself over to the UK as soon as you can, or I'll get myself over to Ireland, whichever's easier.
We'll not go to the politics.
We might be able to do a show in the same room. That'll be fun.
That'd be brilliant.
Do Ronnie's style.
Yeah.
But no, handing you back to our amazing friends at Space Store, who have been so supportive. They've had a good break in the summer as well, I hope. I went off helicopter flying and caving in North Wales and all sorts. It was lovely, getting a bit of a break away from the day-to-day grind, as it were. But yeah, back to Latch.
Yep.
Great. Thank you so much, Nick and Terry, for another great show. I've learned so much. I hope everyone who's tuned in has too. Please do make sure you're subscribed. Make sure you like this video and share it with any space fans. Share it on your Twitter feeds. Share it on Facebook to spread the word about this amazing show every other Tuesday. Remember, we'll be back in a couple of weeks, same time, same place. But before then, if you're around the South Oxfordshire area, please do go ahead and visit our space store in Didcot. We're open Sunday to Tuesday, or Tuesday to Sunday, I should say. And we're open for virtual reality. You can come and have birthday parties, and we host a whole load of amazing experiences. So come down. We've also got a cafe, so come and have a bite there. We could do with your support.
It's brilliant. I'm saying it as an independent. I've been there, and it's fantastic. And VR, I do a lot of work with VR with my day job and stuff. And if you've not experienced VR, it's brilliant. It's just so much fun. Take your kids. It's great.
It is amazing. And we'll have a surprise for you actually in our next roundup. We're not going to tell anyone what it is, but there's going to be a surprise at the start of the next roundup. So tune in on the 21st of September, Tuesday at 7:30 p.m. right here, and we'll see you with a little surprise.
Okay. Bye, everybody.
Adios, amigos.
Good evening. See you later.
Bye all. Bye. Hi, my name's Nick Howes, space enthusiast, author, writer, broadcaster.
Hi, I'm Terry Moseley, past president of the Irish Astronomical Association, lifelong astronomy and space nerd, absolutely fascinated by everything, both man-made and natural, up there.
So every 2 weeks, Terry and I give you the latest, hottest news from space and human spaceflight, robotic spaceflight, and what's happening up in the skies. Please tune in to us every fortnight with the Space Stuff.